Hmm. Okay, no. Yeah. Program not running. OSPF. This customer is job. There are 1 people. They formed MPLS membership. .1.1. Hello. Okay. So yesterday what we were discussing is when I will do trace route. Problem with the trace route is when I'm doing trace route to one customer to other customer, it is showing MPLS route also. That is what I do not want. What I want. It is showing MPLS route. This is what I do not want. So for that, to stop this on the provider edge router of both sides, you have to type this command. command is no MPLS IP propagate TTL. Enter. No MPLS IP propagate TTL, where you have to type on the provider edge of the both the router. Right now I will try from here R1, and if you now you will do trace route, it won't show you the MPLS path. Now we'll see the background why. Okay. So first of all, what I will do, I will convert this back into. First of all, we'll see why it was showing you the MPLS path. So there's an issue with TTL. I've told you you have a TTL field in MPLS also, one TTL field in L3 also. So right now I did a default one where it will show you MPLS path. So we'll see actually what happened. And then we'll analyze also with Wireshark. Now suppose I'll write on a TTL. Normal L3 packet is initiated from here with TTL of 255. Right? Now when packet will move here, your L3 TTL will be decremented to 254. Now normally now your L2.5 is also encapsulated. It has its own TTL. It should be start from 255 right now. But what actually it does, by default, it will copy the TTL of L3. See why it is showing you MPLS path, because it is copying the TTL of L3. So it will make it 254. Okay. On the other hop, when it will reach, okay, now L3 TTL won't be decremented, only 2.5 will be manipulated. So TTL 254 and L2.5 means MPLS TTL will become 253. Okay, this is where a pop will happen. See, now try to understand here, before popping, this TTL will become 252. But now it has to be popped. So what will happen? This 252 will be copied back to L3. This is 252. And this will be popped. And then when it will go to the next hop, L3, TTL will become 251 and it will reach here. Now, see, you need to understand that he is doing copying. That copy, the TTL of what is started, and again when it is exiting from the MPLS cloud, again it is copying to the L3. That thing make it showing that particular concept made him to show all the MPLS paths. Okay, we'll put it like this, and we're going to verify first. How to verify? Just enable Wireshark. And just we need to initiate a ping. Okay, ping will tell you everything. Pinging. Okay, so first here we will notice normally TTL will go with 255. This is 255, right? Then packet will reach here. You will notice here TTL of L3 is 254 and L2.5 is also 254, but it should be 255, but it is copying. So you have to verify whatever I have told you. request. If you will notice, there TTL is to 54 and this is copied to MPLS TTL to 54. Fine. Now you will notice the next hop only MPLS TTL is decremented. You will notice your L3 TTL will remain to 54, but L3 will become to 53 as discussed. Now in the next hop, 252 is copied to the L3 here. Request. If you will notice, it is popped, but see the TTL to 52, whatever discussed. And then on the next hop, we'll send. You can see here also to 51. Okay, so this is what we discussed. Now, after typing that command, so now from here, let me do it on R2. No MPLS IP propagate TTL. Now it is not showing MPLS path. The reason started from L3 TTL to 55. When it reach here, L3 TTL, now you have to compare both. Will become 254, but this time it won't copy. This will say that this time it will say that TTL will be my 255 only. And when it will reach here, L3 TTL will remain 254 unchanged, but your L2.5 will become TTL 254. Okay, when it will reach to the other, it will be popped. It will be popped. So what happen is L2.5 immediately will be popped. Now L3 will be decremented. But it is decremented to 253. And then it will go to this as 252 L3 TTL. Now it is not using at all the L3 TTL, so it has its own TTL. So what happening? What packet is going inside the MPLS slot? I don't even care. So in the production network they do this. Okay, so it won't copy the MPLS TTL. So we'll verify. What I will do, I'll clear this. So we have pinged several times. Now we'll start opening the wire chart. We'll open one of the requests. You will notice here CTL is normal to 55. Remove this. Now here you have to do the change. Any request you will open. You will notice this will be to 54, but MPLS TTL will be to 55. It is not taking the L3 one. Okay. Okay. So just let me see. Okay. Again, I will open. I need to check actually where I was. Okay, I was showing you some detail to 55. Fine. Now we'll go here and we'll verify both should be to 54 accordingly, whatever we discussed. Let me open one of the request packet. You will notice here this is 254, but this will decrement it to 254 also. And then here it will be popped, and it should be 253. But L3 will decrement its own TTL, not L2.5 will do anything with that. Okay, there no relation between 2.5 and 3 TTL. This is very important in the production, but people only type this command, but most of people, they do not know the background of this. So please, in the interview they can ask you 100% this question. This is 3. Okay, and on the next talk it will become 3. 252. Clear? Now, small tweaks are there, I'll let you know. Now, I can give my own labels also, like on R5 suppose. Sometime it won't change, but I'll tell you the command. Now, already changed, right? See, if you are enabling for a new configuration, you can do it at that time only without before enabling MPLS, or there's a command called MPLS label range. I'll say, okay, this is router number 5 for identification. I will say 500 to 599. Sorry, I have to type a space. Enter. It is saying that this will be affected in the next reload. Sometime in the GNS it won't work, but I'll do a reload in front of you. First of all, I'll write the command, okay, and then I will do a reload. So you will notice that a local label is generated with 500 between 599. So that it is locally significant, like we change the LCs manually. Here also we can do it at every router. The issue of GNS. I will do this reload, then it won't affect it. Okay, let's see. So let's see. Show MPLS. So I think nothing has even written. Show run 5 section. Fine, I understood. You need to follow this. Otherwise, GNS sometimes it won't show here, it is not showing and not even saving. So I have to enable again auto config. So you can do that command to change the label. One thing. Okay. I'll try to show you another router. One more issue is there, router ID issue. Now what I will do here on router OSPF1. Okay, I will do here on no router OSPF1. Okay, I'll enable router OSPF1 and network. I'll give a specific network 60.1.1.0.0.0.0.55 area 0 and network 70.1.1.0.0.0.0.255 area 0. Okay, and MPLS LDP neighbor auto config. Okay, now what actually do you decided? You created one loopback address, interface loopback 0, IP address 100.100.100.100. Sorry. Okay, this is you created. Okay. Now what I want is I want that this loopback should be my router ID. See, normally if you have not enabled MPLS, what you can do is MPLS LDP router ID loopback 0. Enter. But right now on the ongoing topology, you want to change the loopback address. You have to type this force command. So you try to enter. Now you will see neighborship will go down. See, the problem with MPLS is if here under OSPF I have advertised 60 and 70. See, in MPLS, whatever IGP protocol you are running, if your reachability is not there. See, in my routing table, if I do not have a reachability, I won't make it as a router ID. If router ID is not selected, it won't do three-way handshake. So if you will notice, I'll show you also properly. Show MPLS LDP neighbor, first of all, gone. Okay. So what I'm trying to say is on R4, see, let me open the Wireshark here. Okay, I'll need to check LDP from 60.1.1.2. This is 60.1.1.1. Now what he's saying this time, my router ID is 100.1.1.1. Fine. And they are saying that whenever I will do three-way handshake, I will do it from 100.1.1.1. Problem is R4 does not know about show IP route 100.1.1. It should be there in the routing table. Okay. So what I will do, that's why I wrote the specific route. This thing I have done. I'll show you why I have done intentionally to show history. That's why I removed it and I put specific route. If I 000, 100 should also be advertised. So what I will do now, router OSPF1. The time I will advertise this 100.100.0.0.0.255 area 0, enter. You will notice, and you will see the Wireshark also. See this neighborship form, it's up. LDP is up. Neighbor is up. So these are small tweaks. You can change the router ID. You can change your labels. Okay. Few more things will come once, like in the next section. What we will do, we'll start MPLS VPN. Okay. Within that, I will going to add few more things. Okay. How the table is formed. Okay. So tomorrow we do not have a class. Okay. So from Monday now we'll start here. MPLS VPN, please revise VRF. MPLS, VPN. Revise your VRF, that's all. Otherwise, redistribution, OSPF, those are basics will come, not that much other concept will come. Only basic commands will be there. Just you have to revise your VRF concept. Okay, VRF and whatever we have done MPLS in these 3-4 days. These are important. Then few more concepts I will explain. A lot of theoretical is coming now. And then with practical. A lot of practicals are there now. Okay, so these all are important concepts. So I'll see you guys on Monday now.